The geometrical ratio Malthus proposes for possible population growth is nothing more than what we know as the principle of compound interest, called by Albert Einstein the most powerful force in the universe. A constant growth rate operates on a larger and larger cumulative population, or bank balance, to produce growth that follows an exponential upward curve. This might not seem like much at first, but in the long run the effects can be astonishing, as illustrated by the old story about the chessboard. The Emperor of China enjoyed the game so much, so the story goes, that he gave the man who introduced it to him one wish. The sly fellow asked only for 1 grain of rice on the first square of the chessboard, 2 grains on the second square, 4 on the third, and so on, doubling each time to the 64th square, a compound interest rate of 100% per square. The emperor quickly agreed to the seemingly modest request, but 2 to the 64th power is 18 quintillion grains of rice, much more than all the rice in China then or now. The inventor did not gain all the rice in China. He lost his head, so be careful what you wish for. The arithmetical ratio that Malthus assigns to the possible rate of increase for the food supply, on the other hand, is also called linear increase, because the size of the total food supply charted over time can do no better than produce a straight line on a graph. It increases only by a fixed amount in each new time period. This assumption about very different possible maximum rates of increase for population versus food is the true basis for his conclusion about misery and vice as our inevitable future on Earth. Naturally then, since everything in his argument depends on these assumptions, Malthus devotes the chapters immediately following his first one to evidence that his assumptions about growth rates are correct. In chapter 2, he begins with the geometrical ratio assumption about the power of population. Here he finds himself on pretty solid ground, because he can point to an example of the kind of increase actually happening. After all, if a thing has happened, it must be possible. For his example, Malthus chooses the newly independent American colonies that had just formed themselves into the United States about the time that he was born.
In the United States of America, where the means of subsistence have been more ample, the manners of the people more pure, and consequently the checks to early marriage fewer, than in any other modern states of Europe, the population has been found to double itself in 25 years.
He takes this doubling time as a conservative estimate, and indeed, in the contemporary world, some populations already have been observed to double in even less than 25 years. So every quarter century, the human race is capable of moving on to the next square of the chessboard. At the maximum rate, doubling every 25 years, the entire population of the Earth could have been produced starting from 2 people, say Adam and Eve, in only 800 years after the appearance of the first human couple. Today, humanity is somewhere between squares 33 and 34 on that chessboard in China, but it has taken not 800 years, but hundreds of thousands of years at the least. Obviously, this steady doubling is not what happened historically. And equally obviously, we can't go on and complete the rest of the chessboard either. Malthus immediately explains why. Since the food supply can't grow on this kind of compound interest schedule, most of the time in human history, population has not been growing at its maximum possible rate. That doubling every 25 years has been only an imaginary potential maximum, not an actual experience of populations in most times and places. In Malthus's words, the population has been held in check by the limited food supply. But how does he know that the food supply increases arithmetically, that is, following a linear sequence? Here he wanders into more uncharted territory.
If I allow that by the best possible policy, by breaking up more land and by great encouragement to agriculture, the produce of this island might be doubled in the first 25 years, I think it will be allowed as much as any person can well demand. In the next 25 years, it is impossible to suppose the produce could be quadrupled. It will be contrary to all our knowledge of the qualities of land. The very utmost that we can conceive is that the increase in the second 25 years might equal the present produce. Let us then take this to be our rule, though certainly far beyond the truth, and allow that by great exertion the whole produce of the island might be increased every 25 years by a quantity of subsistence equal to what it presently produces.
If you examine these statements from his second chapter carefully, you will find no mention of any actual evidence at all. It is a purely subjective judgment on his part. If we could knock down this limit to the growth of the food supply, we might still escape from misery and vice. But can we? In fact, his assumption of a linear increase in the food supply, and therefore also a linear increase in the actual, as opposed to potential, population, fits rather nicely with observed historical trends from 1798 over the next 200 years. So again, we can find a historical example of his assumed pattern. Based on his assumption about growth of the food supply, Malthus predicted the observed nearly linear increase in population that took place just about every 25 years for 2 centuries. In fact, since England now imports a considerable share of its food, the increase in the actual food supply of the island may have been slower than a linear increase. Malthus himself points out that a food supply that can go on increasing forever, even at a purely linear rate, seems crazy when we think carefully about it.
No limits whatever are placed to the productions of the earth. They may increase forever and be greater than any assignable quantity. Yet still the power of population, being a power of a superior order, the increase of the human species can only be kept commensurate to the increase of the means of subsistence by the constant operation of the strong law of necessity, acting as a check upon the greater power.
Even the earliest economists, including Malthus himself, were aware of what we call the law of diminishing returns in agriculture, which says that his assumption of a linear increase in output forever is nonsense. If 10 workers produce enough food from a field to feed themselves with a surplus left over, Malthus says the population will increase and we'll get another worker. If the 11 workers produce enough to feed 12, we'll get the 12th worker. But according to the law of diminishing returns, if you keep adding more workers to that finite piece of land, eventually another added worker will not be able to increase the output of that field enough to allow continued growth. The field will reach its carrying capacity. In fact, in Malthus's day, since most of the economy of every country involved agriculture, those early economists concluded that the whole economy would be forced to stop growing when it reached this carrying capacity in agriculture. The idea of this steady state, when growth was doomed to stop, was the reason that economics was called the dismal science. Once he feels satisfied that he has supported his 2 assumptions about potential growth of population and the food supply with evidence, Malthus turns to the more unpleasant question of just how checks that limit population growth to the food supply might operate, and it is there that we find his famous categories of misery and vice.